Geometry Chapter 6 Review Part 2. Make sure that you have in your theorem folder theorem 6.6 through 6.9 on page 338 of your text. Theorem 6.10 on page 340 of your text. And theorem 6.11 through 6.13. which are found on page 349 of your text. You will have 4 questions that specifically deals with each of these theorems. So it would be a good idea to make sure you have them available for your test. Alright, next you're going to have to be able to identify the special types of quadrilaterals. You will not have a word bank. You are going to have to know the names of the special types of quadrilaterals. So we'll go ahead and go through them right now. One special type of quadrilateral is a rhombus. Now we know we have a rhombus because all 4 sides will indicate congruent lengths. Angles do not play a role in identifying a rhombus. It's just the side length. So if you have 4 marks with the same that are the same on each side of your quadrilateral, then it is considered to be a rhombus. The next special type was a rectangle. Now remember, with rectangles, we have 4 right angles. A rectangle has 4 right angles. A third type of special parallelogram was your square. A square has 4 right angles, just like a rectangle, but it also has 4 congruent sides, just like a rhombus. Alright, so a rhombus, the 4 sides are congruent. Rectangle, the 4 angles are congruent. A square, you have both 4 sides and both angles, 4 angles are congruent. Alright, next let's take a look at a trapezoid. A trapezoid is different from a rectangle in the fact that there are only 2 parallel sides. The other sides are not parallel and they are not necessarily congruent. Remember, with a trapezoid, the 2 sides that are parallel are called your bases. The other 2 sides are called the legs. A trapezoid only has 1 pair of parallel sides. If we have a trapezoid, which has 1 pair of parallel sides, and the legs are congruent, then what we have is an isosceles trapezoid. And the next special type of quadrilateral is a kite. A kite has 2 pair of consecutive congruent sides. 2 pairs of consecutive congruent sides. Those consecutive sides are the 2 sides that touch or form a vertex. So this side and this side, which I am going to highlight in blue, are consecutive sides. And the other two, which are going to be highlighted in purple, would be considered consecutive sides because they form the respective vertices. When you have a quadrilateral such as this, we call it a kite. In addition, if you notice that the opposite sides, which are the two different colors here, the blue and purple, are not consecutive. Right, consecutive sides congruent, opposite sides not congruent, we have a kite. Alright, let's talk about equiangular, equilateral, and regular polygons. Alright, remember that equiangular, all of the angles are congruent. Equilateral, the sides are congruent, and with regular polygons we have both angles and sides congruent. Alright, so let's go ahead and identify the polygon that I am going to put up. Alright, so if we look at the polygon shape that I have drawn, out of your three choices here, the only thing that we are given, remember we are not making assumptions, is that the four side lengths are congruent, so this polygon would be considered equilateral. Alright, our next polygon, if we take a look at it, we see that all three angles have the same measurement, and all three sides have the same side length. We would consider this to be a regular polygon. Alright, next polygon shape. If we look at the marks that are given to us, we can tell that only the angle measurements indicate congruency, so therefore we would say this polygon is equiangular. Alright, and last polygon shape. Okay, no angle measurements are given to us to show congruency. And here we know we have 1, 2, 3, 4 sides of a polygon. However, not all 4 sides have the same marks, therefore they don't have the same measurements. So we would say that this polygon does not meet any of the criteria that is listed above. So we're just going to say it's neither of the above. Alright, let's go ahead and find areas of quadrilateral. Okay, the formulas that you need for the areas of certain types of quadrilaterals is found in lessons 6, 7. They can be in your theorem folder. They are theorem 6.20, theorem 6.21, and theorem 6.22. Alright, so let's say we have a quadrilateral such as this one here. parallel side, and we have a right angle. From the information that's given, we can conclude that it is most likely a rectangle. Therefore, to find the height of a rectangle, it would be area is equal to base times height. So if my base is 7 and my height is 5, then we would say that the area is equal to 7 times 5, or 35 square units. Alright, let's find the area of a trapezoid. Okay, let's go ahead and make our marks here. We have a right angle. These two sides are parallel. Let's say we have 8 feet, 4 feet, and a height of 4 feet. Alright, to find the area of a trapezoid, it is going to be 1/2 of the sum of your two bases. So our base 1 plus base 2. So we would say area is equal to 1/2 of 8 plus 4. One-half of 12 is going to yield us 6. Okay. Once you have found the half of the sum of the two bases, what you're going to then do is just go ahead and take that number and multiply it to the height, which is 4. So area is going to be equal to 24 square feet. Alright, so let me just go ahead and write that over here for you. Area is equal to 1/2 of our bases added together, and then we're going to multiply it to the height. This ends part 2 of the Chapter 6 review. Please look for part 3.